Good morning everyone. In this video we're going to discuss about light. Light is a form of energy which travels as electromagnetic waves, and the branch that deals with the properties and applications of light is called optics. Reflection of light. Light falling on any polished surface such as mirror is then reflected, and this reflection on polished surface, they follow certain laws. The laws are stated below. The incident ray, the reflected ray and the normal at the point of incident all lie on the same plane, and the second point is the angle of incidence is equal to the angle of reflection. So we can see this image. See here, the light is falling on a plane mirror and then it's getting reflected, and see the angle, they both are same. So the incident ray, the normal and the reflected ray, they all lie in the same plane, and the angle of incident ray is equal to the angle of reflected ray. Lateral inversion. The word lateral inversion comes from the Latin word latus, which means side. So lateral inversion means sidewise inversion. It is the apparent inversion of left and right that occurs in a plane mirror. Mirror do not actually reverse left and the right or up and the down, but instead they reverse inside out. This is the difference between the real and virtual image. In real image, light rays actually meet to form a real image. Here they do not meet to form a virtual image. And in case of real mirror, the image is generally inverted. It is inverted. And in the case of virtual image, the image is erect. Erect means it is very straight. And the next point is image can be obtained on the screen. We can get the image on the screen. Here we cannot get the object on the screen. Then the image is in front of the mirror and behind the lens. Here the image is behind the mirror and in front of the lens. We can reach to it. Here we can't reach to it. The picture is given here. See. Okay. So mirrors are classified in this way. Mirrors are classified into plane mirror and curved mirror. Further, the curved mirror is classified into spherical mirror, cylindrical mirror, parabolic mirror, and ellipsoid. Curved mirrors. Mirrors with the curved reflecting surface. As we all know, curve means somewhere it is bent. It may be either concave or convex, and most curved mirrors have surfaces that are shaped like a part of a sphere, but other shapes are sometimes used in optical devices. These are the simplest to make and it is the best shape for general purpose use. Parallel rays reflected from these mirrors do not focus on single point. Terminologies. Center of curvature. Center of curvature means the point in the center of the mirror passes through the curve of the mirror and has the same tangent and curvature at that point. Now, radius of curvature. It is the linear distance between the pole and the center of curvature. Principal axis. The imaginary line passes through the optical center and the center of curvature of any lens or a spherical mirror. Next, pole. The midpoint of the spherical mirror is called pole. Aperture. An aperture of the mirror or lens is a point from which the reflection of light actually happens, and it also gives the size of the mirror. Principal focus means principal focus can also be called as focal point. It is the axis on the mirror or lens wherein rays of light parallel to the axis converge and appear to converge after reflection or refraction. Focus. It's any given point where light rays parallel to the principal axis will converge after the reflector of the mirror. Here's the difference between a concave mirror and convex mirror. A mirror is called concave mirror if its reflecting side is bulging inwards, while that it is the outer side is bulged. And here when parallel rays are incident on the concave mirror, the reflected rays are converge at the focus. Here when parallel rays are incident on the convex mirror, the reflected rays diverge from the focus. A concave mirror forms real and inverted images except when the object is placed between focus and pole. Here concave mirror forms virtual and erect image irrespective of the position. Next, concave mirror magnifies the image of the object at all positions except when the object is placed at the center of curvature. Here a convex mirror always produces a diminished image of the object. Diminished means a small image. Next, the image formed in the concave mirror can be produced and seen on a mirror. Here it cannot be seen on a mirror, seen on a screen. And the examples of concave mirror are telescopes, torchlight, automobile headlights. While here it is optical instruments, rear side view mirror of vehicles, and calling bell. Rules for image formation in spherical mirrors. A ray passing through the center of curvature is reflected back along its own path. A ray parallel to the principal axis passes through or appears to be coming from the principal focus after reflection. A ray passing through the focus gets reflected and travels parallel to the principal axis. A ray incident at the pole of the mirror gets reflected along a path such that the angle of incidence is equal to the angle of reflection. So image formation concave mirror, position of the object, position of the image, nature of the image, and ray diagram. So at infinity, this set focus, the position of image is set focus, and the nature of image is real, inverted, and diminished. We can see the ray diagram here. Then in case of beyond C, the position of image forms between F and C. The nature of image is real, inverted, and diminished. Then in the position of C, when you place the image at the position of C, the image formed is at C and real, inverted, and at the same size. When it is placed between F and C, the nature of image is beyond C. The image is real, inverted, and enlarged. When it is placed at F, the nature of image is infinity. Then image formed is real, inverted, and highly entangled. While in case of between F and P, the image formed is behind the mirror. Image is virtual, enlarged, and direct image. Image formation in convex mirror. Position of the object is at infinity. Position of the images will be formed behind the mirror, and the size will be highly diminished. The nature of the image will be virtual and erect. Between infinity and the pole of mirror means the position of the image between P and F and behind the mirror, the size of the image is very diminished, and it is virtual and erect. So use of concave and convex mirror. So concave mirrors are used as shaving mirrors, makeup mirrors, and they are also used in dentist mirrors. Then they used in torches and solar furnace. And use of convex mirror, they are used in vehicles. They're used in vehicles, and they're also used in security. They're also used as shop security mirrors, that is traffic mirrors. Refraction of light. We have seen reflection of light. Reflection means imitation or something, copying something. That's really reflection. The same image is formed in other side. That's it. In case of refraction, bending. The best example to explain this is a pencil inside a glass of water. When we see it, we have feeling like the pencil is bended, but the pencil will be straight actually. So the bending of light rays when they pass obliquely from one medium to another medium, light rays get deviated from the original path and they enter into a transparent. They enter into a different optical density. This deviation of path is due to change in velocity of light in the different medium. The velocity of light depends upon the nature of medium in which it travels. Snell's law of refraction. This is also called as law of refraction. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the same point of incident all lie in the same plane. So the formula is sin I by sin R is equal to constant. There incident ray is equal to reflected ray. Here sin I by sin R is equal to constant. Total internal reflection. Complete reflection of a ray of light within a medium such as water or glass from the surrounding surface is black into the medium. The phenomenon occurs if the angle of incidence is greater than the certain limiting angle, called the critical angle. So what are the conditions for total internal reflection? Means through the denser medium, the angle of incidence must be larger than the critical angle for this kind of combination of media. All light ray might move from a denser medium toward a rarer medium. So the applications are mirrage and optical fibers. Let me explain this. Imagine you're traveling in a bike, and sometimes the road, when you see the road, it may look like there's some water, but when you go closer, the water won't be there. So this is due to total internal reflection. These are my references. Thank you.